So you may be wondering, how do I graph something? Particularly, how do I graph something that has a slope of 3/8? It's a fraction. How would I graph something with a negative slope of negative 2/3? Or maybe a slope of 5/2? So these are all, the first three of these are all, of course, slope-intercept form equations. And so the first part you would want to do with a slope-intercept form is just pick a point that you're going to be working with. I will use the red point. So the first thing, I apologize, I get interrupted there for a Roblox moment, but let's see here. We've got y equals 3/8 x minus 4. So start off by just plotting that y-intercept. So I'm going to grab a blue point, and I'm going to just move it over. I'm using my arrow keys to move it over. And I'm going to bring it down to a y-intercept of -4, because y equals mx plus b tells me that that -4 is in the y-intercept position. And of course, that's the cheat code, but of course, just the fact that x is 0 puts you on the y-axis. So if x is 0, we don't care about 3/8 times x. We just have y equals -4. So we've got that. Now we have to find a second point, and the slope will tell us a second point. So that fraction says 3/8. And if you recall, slope is the change in y over the change in x. So it's super convenient that that is 3/8, because it is telling us the change of y over the change of x. So that's a vertical change of 3 over a horizontal change of 8. So what we're going to do is we're going to grab another point, and I'm going to just drag it over. I'm going to just put it right there on top of my other point. And I'm right here, and I'm going to be going 3/8. So up 3, so that numerator is the vertical change, and then over 8. And now I have a second point. I could have converted that fraction to 6/16 if I wanted, and I could also have just, I could have taken a point here and plop it down here. So 3/8 could be, of course, converted into equivalent form. So instead of up 3/8, up 6. So let's see, from -4 to 2 to +2 is up 6. And then over 16. You can see they line up rather nicely. I could also take 3/8 and I could convert that to -3 over -8. So instead of going up 3 and to the right 8, I could also go down 3. So line it up with my y-intercept. So down 3 to -7, and then to the left 8. And now I have these points. Can I move this? I can do that. Okay, I now have these points all nicely lined up. I really only needed 2, but I wanted to illustrate how you could find a bunch of points. So I'm going to grab a line, I'm going to drag it over here, and I'm just going to, because I was working with paper, I would just get a ruler or any kind of straight edge and draw a line through. Okay, so there is my line. It has a y-intercept at -4 and a slope of 3/8. Everywhere on this line, it's up 3/8. That fraction says up 3/8. Now let's find a line for y equals -2/3 x plus 5. So I'm going to use red for that one. Red. So that means I'm going to have, come on, click on there. Let's move it. So we have a y-intercept of +5 here. I'm going to go over here and up to 5. If x was 0, y would be 5, because -2/3 times 0 plus 5 is 0 plus 5. And so I have a slope of -2/3. When you have a negative slope, that means the vertical change and the horizontal change are going in kind of opposite directions. So if vertical change is positive, horizontal change is negative. Vertical change is negative, horizontal change is positive. So let's grab this other red point and drag it over too. And we will map another point using the slope. So I've got -2/3. Now, once again, that fraction is the vertical change over the horizontal change. That negative could be plopped in the numerator or denominator, one or the other. Doesn't matter, just use it once though. Okay, so I'm going to use it as down 2. So that's a 2 for in the numerator is the vertical change, so down 2, and then horizontally over 3. I'm not terribly satisfied with having a point that's that close, so I'm actually going to do that one more step. So down 2 again, and over 3. So now I've got I'm at 6, 1. Okay, so I could do that. Okay. I'm actually making an extra point. I'm going to go back up. So I left a point right there. I'm going to go back up to my original y-intercept spot. And this time I can also go up 2 and back 3 because that's positive 2 and negative 3. Do it again, positive 2, negative 3. Really, essentially, now I'm making it a positive 4, negative 6, because that's the same as negative 2/3. Now I have 3 nice little points there, all nicely lined up. Let me grab this line, make a copy, and then move it up here. Drag it around until I get it where I want it. Okay, so the other thing to think about on a negative slope is you're going to be going down to the right on negative slopes, up to the right on positive slopes. There you go. We got a pretty good mapping of that line right there. Okay. If I'm trying to find the intersection point between these two lines, it seems like it's right about 8, negative 1, by the way, and maybe that's the solution. I would probably want a more precise graphing to be really sure, but it looks pretty good to me. Let's graph the next one. The next one we have y equals 5 halves x minus 9. So I'm going to grab this green point, and I'm going to bring it to my y-intercept point. So that's the first thing to do, get an anchor point, bring it down, bring it down, there. Boom, 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 boom. Okay, now I'll copy it, paste it. Now I've got an extra point there, and I need to map a slope of 5 halves. Once again, the numerator over the denominator, vertical change over horizontal change. It's positives. They're both going in the same direction. So I'm going to go up 5 over 2. I could also make that up 10 over 4, which would be the same as 5 halves. So I'm just going to go up 5 from, actually I'm going to go up 10. Up 10 and then over 4. So up 10 from negative 9 will put me at 1. And then I'm going to go over 4. And I have a point that's nice and far away. So it'll be easier for me to get my graph. Okay. Now I'm going to copy and paste, right? Copy paste of that and leave that point right there. And I want to show you what it looks like if I also just go up 5 over 2. So up 5. And then over 2. Now you see they're nicely lined up. It's right there. I can make a line right through those points. I'll just grab this line. I'll make a copy. And I will drag it to where I want to drag it. Flump. Come on. There we go. And flump. Like that. See, is that right? Up 5 over 2. Okay. The points aren't exactly lined up right, but we're going up 5 over 2, up 5 over 2, and that's how you would do that. Okay, the last one I want to give you is a standard form one. And the standard form one, I'm giving you one where you're only going to be able to get one of the intercepts nicely. The other one's going to be annoying. Okay, so we can find the x-intercept rather nicely. The x-intercept is going to be, so this is, of course, in the ax plus by equals c structure. And so the x-intercept is going to be at the point c over a, comma, 0. And the reason for that is the x-intercept is where y is 0, so we don't care about the y. So the y goes poof, and you're left with just ax equals c. Divide both sides by a. to solve for x, and x will equal c over a when y equals 0. And so that is, of course, the definition of an x-intercept. So I've got an x-intercept. If I needed the y-intercept, it would be 0, comma, c over b. All right. Now, the next thing you need to know is, of course, how to get the slope. Okay, and I've put cheat codes for you in the notes in the big document, particularly under linear 7, for how to do that. Okay. Well, 0 c over, actually, hang on, before I talk about that, let's talk about what these intercepts are. So c over a, c is -9, a is 3. So that's going to be a -9, and a will be 3. And we can reduce that into -3. -9 over 3 is -3. The other one, I've got -9 over 4, and that's going to be fractional, which will be a little harder to plot. It's not impossible, but that's basically -2.25. Okay, you can eyeball it if you have to, but there's another option. So let's grab this point. First thing I'm going to do is I'm going to plot a different color. Make it purple. Okay, and we can plot this as an x-intercept. So we're going to plot an anchor point. So we're going to plot -3, 0. That is our x-intercept. So it's useful to just mark a point. Okay, and now I've got an extra dot as well that I can work with. Okay, cool. So there's my x-intercept right there at -3, 0. And I moved this one a little off so it's not in the way. I now need the slope. So slope from a standard form equation is the negative of a over b. And since a is 3 and b is 4, I have a slope of -3 over 4. So that's -3/4 for my slope. So I'm going to map another point using that slope. Let me go here. Okay. So I'm going to go down 3 because that's vertical change over horizontal change. So I can go down 3 and then over 4. I can put a point there. I can also, just for good measure, I can go up 3 and back 4. And now I've got a nice little row of points that I can grab. Let me copy pasta this line. I'll drag it where it needs to be. And there we go. You've got your base. Not perfectly lined up. We could do it a little better than that. There, maybe that's a little better. Because we're going through -3, 0. Okay, down 3 over 4. So that's the -3 over 4 slope. Down 3 over 4. Up 3, back 4. Both of those represent a -3/4 slope. Now, sometimes people actually, so I know the person who asked for this video asked for stuff about the fractions. I'm going to make a point about a whole number slope as well real quickly. Y equals 3x minus 6. And if some people get stuck on the whole number ones, remember 3 is just 3 over 1. We could also express that as 6 over 2. Okay, so now you've got a vertical change of 6 over 2. I could express that as -9 over -3. That's the same thing as 3 over 1. All of those are just different ways to say 3 over 1. And so they give me options of how I map a point. So I will grab a point here. Let's make it another color. Let's make it olive green. Okay, so we're going to plot our point. Our first point is our y-intercept, which will be at -6 because, hey, look, there's the y-intercept at -6. So we go down to -6. We are at -6. Now, I'm going to copy that point, and I'm going to make another point. I can go up 3/1 from there. 1, 2, 3/1. Now, that's really close by, so I'm not super psyched about that. So instead, I'm going to go back here, and instead of going up 3/1, I'll go up 6. There, from -6, I'll end up here in over 2. And those are a little farther apart. I'll go ahead and copy another one of those, and from here, I'll go up another 6 and over 2. So up to 6, over to 4. And now I've mapped 3 points, and I can make a copy of this line and line it up a little bit. Let me bring it, oops, wrong line to bump. Okay, I know it's getting like a crowded field here. Okay, bring that there. Bring this here. Looks like I'm a little off there. Let's see. Yeah, I'm still a little off from there. Go over there. That's a little better. And grab that point and move it slightly over, and I think I'm in the right place now. And now I've got my line for y equals what was 3x minus 6. And I'm using the fact that 3 is the same as 3/1 or 6/2, or I could have used -9 over -3. And there you have it. I hope that has cleared up some things for you.